Welcome to qnawire.
Hi there. In this question, we want to know the hybridization that is required for each of these bonds. So we're looking for the hybridization of each atom in the bond. All right, and letter A has been done for us already, so let's start off with letter B. In letter B, we have a carbon that is double bonded to a carbon, and then each of these carbons has two single bonds. All right, so therefore, each of these needs 3 hybrid orbitals. So the first carbon will be sp2. That's how it gets 3 hybrid orbitals, by blending 1s and 2p. And the second one will also be sp2, because they both need 3 hybrid orbitals. So letter B would be sp2 to sp2. Let's look at letter C. Letter C, we have a carbon single bonded to a carbon. And each of these carbons then would have 3 other things bonded to them for a total of 4, since it's a single bond there, and there are no other double bonds on these carbons. So that means they need 4 hybrid orbitals. So this would be sp3 to sp3. All right, letter D, moving along here. Letter D, again, it's just like letters. Oh, no, it's not. Sorry. Let's draw this. We have a carbon bonded to another carbon that has a double bond and a single bond. And this one to the left just shows single bonds. So there will be one to a hydrogen that's not shown. All right, so we have a carbon that needs 4 hybrid orbitals. So it's going to be sp3, bonded to a carbon that only needs a total of 3 hybrid orbitals. Therefore, sp2. Notice we just need to make sure the superscripts add up to the total number of hybrid orbitals that we need. S always just has 1 orbital, and then the p we need to adjust accordingly to get the number of orbitals that we need. All right, letter E. Okay, letter E is a little more challenging. We have a carbon single bonded to another carbon, but our first carbon, or the one on the left, has a single bond and a double bond. So that means it needs 3 hybrid orbitals. So it's going to be sp2. Our other carbon has a triple bond attached to it. So all it needs is 2 hybrid orbitals, making it sp. All right, and then letter F. Letter F, we have an oxygen. This oxygen is double bonded, and then this is single bonded to a hydrogen. This oxygen is positively charged, so normally oxygen has 6 valence electrons, but this one will only have 5. So that means it still has 1 lone pair on here. So this oxygen needs 3 hybrid orbitals. Therefore, it's going to be sp2. And then we have that bonded to a hydrogen. Well, the hydrogen simply has an s orbital. So we have an sp2 to an s, or looking at the answer options, it appears you could write those in reverse order. Looks like the order does not matter here. So you would look for the s, sp2. All right, just like in the previous one, you would look for the sp, sp2. So the order does not matter in these. You just want to match up those 2 types of hybridization in the answer options, even if they're listed in the reverse order from what I have them here. All right, that concludes this question. Thanks so much for watching, and I hope this was helpful.